All right. Hello, all you cool cats and kittens. Oh wait, that's the wrong show. Uh, Happy deploying. Welcome to the Roboflow live stream. It's been a while since we've been here on the YouTube doing some fun stuff, but let's have some fun on this Friday afternoon. We are going to do a roast of a data set that we find on Roboflow Universe. So basically, the idea is the best way to learn is by making mistakes, and let's learn from somebody else's mistakes. So we have this open source community of over 200,000 data sets that users have shared on Roboflow. Some of those are really good, and some of them are not so good. And let's go through and see if we can find one of the not so good ones and turn it into the ones that is pretty good. Before we get started, let's make sure that everything's working okay. I don't want to go through this whole thing and realize I forgot to connect a microphone or something like that. If there's anybody in the chat, can you give me a thumbs up or a hello? All right, I got confirmation that the sound is good and we are in fact streaming. So let's jump in. I've gone here to universe.roboflow.com and we're going to find a project that somebody has uploaded with a model. You can upload all sorts of models to Roboflow, but we're going to dive into the latest and greatest YOLO v8. So here we've got hundreds of models that people have uploaded. We'll just try and go through and find one that we want to use for this. Let's see. I saw a dollar bill detection one. So it looks like this one has a model. This one actually looks maybe pretty good. Let me actually have some. Hang on, let me grab my wallet. Okay, so I actually have some money here. Let's try this out and see how good this model is and if this is one that we can maybe improve. Actually, it looks like it's detecting 5 front on that and 5 back on that. That looks like a pretty good model. I don't know that we're going to be able to improve that one very much. Let's go back and check out some of these other ones. See if there's anything else in here that maybe I have at my desk. Waste. This one looks like it's supposed to detect like bottles. Oh, but is it? Oh, this is a segmentation model. Let's not do this one. This one looks pretty good too. I think I saw a coffee cup one up here. Let's try that out. Actually, I can already see from the thumbnail that this one looks like it could use some improvement. Like they only labeled one of these coffee mugs. So if we go into this model, oh, and it looks like, so the model's not even detecting any of these mugs. So if I reduce down my confidence, I can see it's making predictions, but this only got 1.88% MAP. That's really not good. These kind of look like random predictions. Ooh, what are Gellas? It's interesting. It's predicting. This looks like a good one to use. I bet we can improve this. Let's look at the images and see what's going on in here. Looks like there's a whole bunch of stuff maybe pulled from like Google image search. Oh yeah, look at this. And only some of the mugs are labeled. Let's see. Let's check out the dataset health check and see what we got. So we've got a bunch of classes. I don't know what these are. Looks like some of them are coffee, some are coffee mug, some are zero, some are cup. Interesting. Okay, yeah, I think we can improve this a lot just by telling the model that these are all the same thing, coffee mugs. And if I want this to work with my webcam, let's try that out. So there's 2 models. There's a YOLO v8 model with 1.8% map and a Roboflow train model with 10% map. Did this do any better? Nope, this one's still not great. Let's try this with my webcam. Got a coffee cup. Okay. Is this doing anything? Whoa. No. Okay, so goal of the video. Let's take this data set, improve it, and train a model that's going to do good detecting me and my coffee cup here. Okay, first things first. Let's get this into my Roboflow account. So I created a new account just for this, the purposes of this stream. So let's go ahead and create a project here. I'm going to detect coffee cups and call it coffee cups. Okay, and I'm on a public account, so this is going to get shared on Roboflow Universe also. And then instead of dropping my images in here, let's go ahead and come over here to Roboflow Universe, and let's just select all of these and copy these over. So we're gonna duplicate this project. I think I got them all. So I'm going to click clone, and then I'm going to select that new project, and let's pull these into my Roboflow account. Okay, so we got 144 images. Let's pick one of these as our cover photo. How's this one? Okay, so we got a computer vision project here. Let's run the health check and see, just make sure that it pulled in all that same stuff that we got from Roboflow Universe. Okay, so I think the first thing we want to do is fix these classes, but let's go look at the images and see if there's anything else we notice about things. If you guys notice anything in the chat, or if you notice anything, put it in the YouTube chat, and we'll work on this together. So I'm going to go into this data set, and let's check out this stuff. Actually, so for one, all these classes are weird. Gellus, Cup, Gellus. These all look like stock photos, so I think I'm going to need to get some with people. We're definitely going to have to fix the ones that are missing in here. Ooh, that one's got weird borders. I think I might remove some of these, but we'll hold off for a second. That's clip art. I don't think that's really going to help my model learn anything. Whoa, that's a lot of cups we didn't label there. I don't know what's going on with some of these. All right, so we got a high-level overview. I think there's a few things. One, obviously the classes are kind of a mess. Two, not everything's labeled. Three, there's no people in these, so if I'm holding my cup, that's probably going to confuse the model. 4, what else? Let's go back to that project on Roboflow Universe and look. I'm actually kind of curious what they trained this model on. Whoa. Okay, so there's another problem right there. So it looks like these outputted images here. I bet if we look at these are going to be nonsense. So this is junk. This image here went from that, and then after all the transform steps are applied, this is what the model saw. So no wonder it didn't learn anything. Looks like they really went wild on the augmentations here. Okay, so that's an easy thing to fix. I bet if we change nothing else besides the classes and just getting rid of a bunch of these augmentations that they applied. What happened on the first one? Is that the same? Oh, even more. Bounding box augmentations. All right, so I bet just remapping the classes and then getting rid of some of the augmentations and making it more of a realistic data set is already going to improve our map quite a bit from that 10%. So let's do that. Let's remap these classes, generate a clean data set, kick off a training run, and then we'll go inspect. Oh, hey, Joseph, what's up? It's like my co-founders in our crisp chat. Let's demo something else here. Quick Roboflow commercial. We launched a new feature powered by GPT-4. You can actually ask a question. Let's see. What augmentations? And it uses GPT-4 to answer your questions. So I can ask it kind of whatever I want. And it's read all of our documentation, blog posts, looked at all our YouTube videos, and it should have an answer for me here. So I'll close that until GPT-4 replies. And then let's come over here and go ahead and do modify classes. So basically, I think everything that was labeled in here were coffee cups. So let's just do mug for everything. So this is going to take the existing annotations in the data set that we have, and it's going to remap them all to mug. So instead of the model seeing all these different things and trying to understand what the difference between cup and coffee mug and Gillis is, which are all the same, so there's nothing for it to learn there, and it's probably getting confused. We'll do that. And then let's apply some normal augmentations here. So thinking about what to do here. So we shouldn't do vertical flip because these scenes aren't going to be upside down. Oh, Joseph's going to hand me over to GPT-4. Hang on. We should not do this. The coffee cups aren't going to be sideways. We can zoom in a little bit. Maybe like a little bit of rotation, but not much. Kind of like shear. Let's do a touch of shear. The goal here is to make my augmented images look pretty similar to things that are not in my data set but that the model might see in the wild, so that it learns not to just memorize the exact images in my data set. So we're just applying some minimal augmentations here. Nothing like that other data set where it was going to completely nuke the model and make it just see random noise. I think that looks pretty good. So here I'll go generate. I'm going to do a 3x augmentation. So we're going to go from 144 images to about 364. And let's ask GPT-4 again. Let's see if it agreed with my things that I decided on. Sweet. So we're using Kappa AI for this, and they're sending this to GPT-4 for us. Let's see how it does. Oh, nice. It looks like my chat hadn't been working, so I refreshed the page, and now I actually see your guys' comments. Shane says I type with force. Yeah, I'm a very forceful typer. Jacob asked what the starting map was. We had two models. One was 1% map and one was 10% map. And our CTO for a day is giving me props. Salo, congrats on that promotion. And it looks like GPT-4 has replied. Okay, so they think we should do grayscale and flip and brightness. We did flip and brightness. Why does it think? We might try grayscale. Let's try without, and then if it doesn't do well, we'll see. So just to start off, I mean, looking at these images, like these actually look more like things that the model might be able to learn from. Still not great. Like, I don't know why this is annotated this way, But we'll fix that later. Let's just see what happens if I just kick off a train on that. And I bet that'll be done training by the time we're done with this next step. So next off, I want to get maybe like a higher level understanding of what's in this project. So I'm going to use a new feature of Roboflow called vector embedding visualization. So we've got this notebooks repo, which just crossed 1,000 stars today. Props to Peter for all the hard work he's been doing on this. If you're watching on the stream, go to roboflow.com/notebooks, and we'd love some more stars here. But we're going to use this brand new notebook called Vector Analysis with scikit-learn and Bokeh, and we're going to open that in Google Colab. And then, let's see, make sure I'm on a GPU runtime. Cool, looks good. And let me make sure this is going to kick off while we're working. You guys still hear me? Did my internet cut out? We still live in the chat? Somebody, there we go. Okay, so we're booting up a training machine. We'll let that run while we do our stuff over here. So I'm gonna install the dependencies here. While we're waiting for that, how's everybody doing in the chat? What did you think of launch week? Anybody have a favorite launch or feature or blog post that we came out with this week? If you haven't seen it yet, roboflow.com/launchweek is pretty epic. Every day this week we came out with new features. We had announcements. We have open source projects. We have partnerships. There should be something for everybody here. So check it out if you haven't seen it yet, and let us know what your favorites are. We're actually going to use a couple of these in this video today. One of those new things is our new auth method. So you don't have to be pasting your API key around and saving it in your Jupyter notebooks anymore. You can actually just do roboflow.auth, and that should log you in theory. Let's try that again. Oh, you know what? Do I need an API key first? No, I've got one. Uh-oh. I don't know what's going on here. Let's restart this. Gene in the chat asked if I think I'll make it without more images. I think we're going to make some synthetic images because I didn't like that there were no images in there with people in them, and I want it to work with my webcam, and I'm a person that's probably going to be in that, so we'll try and do that. There we go. Okay, so now in this notebook I can, oh look, we're off in training. We're a third of the way to beating that other model already. So I just paste this in here. We're gonna pull from the Roboflow API the vectors for this. Oop. 401, not accessible for provided workspace. Oh, why does that say project? That shouldn't be project. It's always fun to do live demos. Okay, now so we're pulling from the right thing. We got our vector embeddings. we're going to fit tsne to this. So we're basically reducing the dimensionality down from 744 to 2. And then let's visualize our classes. Okay, so first thing we notice is that all these random classes look pretty scattered around here. So they're like, the images aren't that semantically different. You can definitely see that they all came, looks like this was a combination of a bunch of different data sets. And so these vectors, they tend to be clumped, but they're all coffee mugs. All coffee mugs. But you can see there's like some with white background, stock photos. So just getting an idea of some of the outliers. Oh, those look different. So these ones are out here. Looks like they're sideways. Looks like somebody maybe augmented them first and then added them to the data set. That one's upside down. That one, the labels look, that they didn't label the coffee cup there. They labeled something else. So I guess our remap on that one might confuse our model a little bit. But overall, I don't know. Looks like nothing's too far out of here. It's not like we have any that are not coffee cups. I'm actually curious now. So if we go back in here and go to dataset, I'm curious if any of these do have people in them. I didn't see any when we were looking. Okay, so let me go no. How many have hands? Couple. Okay, so that's definitely something I'm going to want to do is put some where it's going to work better with my webcam. Let's go back over here and look at how our train test split is. So I'm going to color these, instead of coloring them by class, let's color them by train test split and just see if they are semantically the same or different. Not bad. Test set's pretty well spread out. Val set's pretty well spread out. Train set's pretty well spread out. So that looks pretty good. I think we're going to nuke these train val test set splits, though. And let's... I want to understand how this model is going to do when I run my webcam on it. So let's construct a val set of just me with my cup on my webcam. And then not use any pictures of me in my room in our training set so that we're not overfitting on that. But that should give us an idea of how this is going to run with somebody else's webcam. Okay, so we're off in training here. Oh, wow. we're already at 40% map. This is going to do a lot better. This is going to do a lot better. I'm pretty stoked about. Man, all we did here was remap those and turn down the augs, and we're already 4.5x better than the best model on the one we started with. But okay, let's rebalance our splits here. Generally, you shouldn't rebalance your splits because this is going to invalidate our testing against the universe model, because we're training against something else, or we're validating against something different. But let's see. I'm going to leave a couple in the test set because I think it's going to complain at me if I empty it. But we're going to empty the val set. I'm going to add new images to the val set here, and we're going to put most of these in the training set. Okay. So let's figure out what's the best way to get. Can I do a QuickTime recording while I'm live streaming? Jean asks, what's map? It's mean average precision. So we actually have this blog post that explains how it's calculated, what exactly it is. But for our purposes, we can just use it as kind of a synonym for accuracy. The higher, the better, in terms of like how much the model has learned and how much it's predicted. This is also something you probably could ask Kappa, and it would answer, and you could actually have a conversation with it if you have further questions about it. Okay, cool. So we're training here. I'm going to open QuickTime. And let's see, do a new screen recording. Or no, new movie recording. this over here. Okay, so let's grab my coffee cup. Okay, so I've got a recording. Looks pretty good. I'm going to save that as coffee on my desktop. And we're going to use that as our new validation set. So go back to the upload page over here. I'll select a file, go on my desktop, grab coffee.mov. Oh, of course it recorded it in HEVC format. Well, let's use my new superpower. How do I convert coffee and I don't want the plugin one. Let's just ask GPT-4. Okay, so it's telling me to install FFmpeg. I think I have that. The other thing we could have done here is use Safari, because Safari supports H.265, but Chrome doesn't. I think it's going to be easier to just use FFmpeg, though, to re-encode my video. I should have told this limit pros and just give me the command, but okay. So it's going to explain it to me too. I don't really care. I'm just going to... Coffee.mov, coffee H.264. All right, and fingers crossed this will work. If it doesn't, we'll tell ChatGPT the error and it can fix it for us. Oh, I don't know why my webcam went giant here. Let's fix that. I bet these images are giant. How big was this file? Oh, wow. That short video was 321 megabytes. I should have had it downsize it as it did it. But, okay, so let's just make sure that... Ooh. Okay, QuickTime can't open this anymore. Is Chrome going to be able to open this? No. What did it do here? Okay, how about let's have it give it a second shot, and let's delete the one that it created. WebM with VP9. Okay. I don't really even know what VP9 is. Never heard of that. I wonder if I'm going to have this installed on my FFmpeg. Okay. let's check in on how our training run is going while we're waiting for that to convert. Okay, we're up above 60%. I bet this is going to actually train well enough that that it might recognize something in my webcam stream. We'll see. Even though it has no people and it's gonna be weird, at least it might be finding some cups. Still rolling on the video conversion. While we're doing that, why don't we start relabeling some of these images? So I mentioned later on we're gonna do some synthetic data. So I'm gonna actually need some polygons of mugs. So let's just go through and do a couple of these. So we're using the Smart Polygon tool in Roboflow here, using ML to create ML. It's pretty meta. But basically you click on the parts that you want or don't want, and there's a model in the background that is creating the mask for you. And we're just going to do it pretty quick. If you were doing something that was mission critical, you might want to spend a little bit more time on this than I am, but I can already see one problem I'm going to have is that the resolution of these things is pretty different from each other. So when we synthetically put them on another background, they're going to be all different sizes from each other. Oops. You know what? I'm realizing that I probably don't want to do this for all of these on this video, so I might need to split some images off into a separate data set that I'm going to use. Let's go ahead and do that after I finish these mugs. Also, my FFmpeg is still going. This VP9 codec must be pretty compute heavy. Oops. Okay. So let's see. How do I want to do that? Let's do like let's go back over to this universe data set and just select some images specifically to pull into this data set that look similar to ones that we're going to want to composite. Like that one. I'm gonna mostly go with like white mugs because that's what I'm gonna be training it to recognize. Okay, that seems like plenty. So clone those and put them in my source images. I think I'm just gonna pull the images this time, and then I'm just gonna label them. Gosh, this VP9 encoding is still going. It's going at like 20x slower than the video speed. That's kind of crazy. Okay, so annotate these, assign them to myself. And then let's just use that same Smart Polygon tool that I was doing before. Okay. Actually, I'm going to... Yeah, synthetic cups, that's fine. So we're going to remap these all to cup again, so the class doesn't matter. Cool. Looks good to me. Looks good. Looks good. And looks good. So one thing that's going to be annoying is that there's going to be white space in here because we don't support donuts on these, because most models can't, for instance segmentation, can't do that. So synthetic data might look a little bit weird, but we'll see how it does. I just want all these in train. Okay, and then let's do some background. So we're basically gonna take those images that I just made and paste them on top of things. So I think I want people like webcam backgrounds. Let's see. And let's go to universe and find some that look like that. Okay, oh, actually, before we do that, this finished processing. So now I've got a coffee.webm. So let's go ahead and go back to our, this one that's still training. Oh, wow. It was up to 74% map, and then it trailed off. I bet that's going to be our high water mark. So the way this works is there's early stopping. So once that val accuracy is the highest for a certain amount of time, it looks like this is leveled up, it'll stop and we'll be able to try that model. Okay, so we're going to go in here. Fingers crossed on this WebM. WebM files are not supported. ChatGPT, you're failing me. So third tries a charm with ChatGPT. It's hit or miss when you don't understand what the commands you're running are. Let's see. I'm gonna look at the chat here while we're talking. Oh, could not find tag code. Codec not. Well, iterative here. I wonder if I could have saved it as something different right from QuickTime. Might need to look into that next time. Overwrite, yes. All right. This one's at least going 5 times faster instead of 20 times slower in the video. That was quick. Success. Okay. So this is going to slice up that video into frames and add them to my data set. And we're going to add these to the validation set to see how the model is going to do. I think it was like 20 seconds. So, oh yeah, 19.6 seconds. So let's do like 3 frames per second, get 60 images from that video. And then we're going to label these quick and use that as our val set. And then that way we'll understand how our model is doing on this in particular. I'm going to add a tag to these and say Brad webcam. Okay, so anybody in the chat want to help me label the mugs in these while I work on the model? Let me know if you do, and I'll invite you to this workspace, and you can label while we're checking out some of this other stuff and doing the synthetic data. Okay, so for the other project, we were gonna grab some people on Zoom calls. Let's see, Zoom business meeting. I suspect somebody collected data sets like that for another purpose. And I just want student check-in. I just want a single person full screen. Kate says she'll help. All right, Kate, I will add you to this workspace. And if you need help, tag team in somebody else also. All right, Kate should have an invite, and I am assigning you all 59 images. Okay, so these should be magically labeled by our friend Kate. Oh, nice. Shane says he'll help too. Shane, I don't know your email off the top of my head though, but maybe if you message it to Kate, she can divide and conquer with you. Okay. Maybe let's instead of that do like webcam view of person in room. Like I just want something that looks kind of like me looking at you here. What else would be a good way to describe semantically what I'm looking for? It's just like front face person. Data, face detection. Oh, that's a good Mo. I know Mo has a good face detection data set that he's done. Let's see if Mo has any photos in here that we can use as our backgrounds. So, oh, nice, portraits of people. I like that. Okay, so we're gonna use my buddy Justin Brady. Let's see. Let's use one of Mo. Let's use. What else do we have? Oh, that one's got some hands in it. That's kind of fun. I almost wonder if a rock, paper, scissors data set would have been a good one here. Because it would have people's hands and faces in them too. But this will probably be sufficient for our purposes. Well, face mask, that looks like a good addition. And let's find one more. How about one with two people in it? Okay, so we've got 8 images. Let's put those in our backgrounds. And I just want these raw images. And then we're going to use a tool called Magic Scissors. And the way that works is you give these a drop zone, which for us is going to be the whole thing. And this is where the mugs are going to be able to be dropped. And then it's going to copy the images that Kate is labeling, the mugs from those images, and composite them on top of these and label them so that we can add them to our data set as synthetic data. And hopefully then, instead of just only mugs, it's going to know what mugs in front of people look like. do here? Really doesn't like this one. Okay, I don't know why it doesn't like J. There's something wrong with that photo. Okay, so I annotated 7. I'm gonna ignore this 8th one for now. I'm not sure what's wrong with that, but we can dive. Oh, there it. Is this just like a giant image? Is that why? Okay, we'll do that. Okay, so we've got 8 images, adding them to the data set. Again, I'm gonna do all test train set. Ooh boy. I shouldn't have spam clicked it. It doesn't like me anymore. I suspect my computer live streaming and doing all this stuff at the same time and video compositing is not making it have a good time. Okay. And then let's see how Kate is doing so far on our val set. She's got 1 done. Kate, you're going to have to go faster than that. Okay, so what we're going to do now is we're going to take these backgrounds, and I'm actually going to add an icon to these. Use it as cover photo. Just so that we know what we're looking at. And source ones. And then we're going to go to magicscissors.app and copy paste our Roboflow API key in here. And that's going to pull, so these are from our workspace, is pulled from the Roboflow API, what we have available. So we want to select our objects of interest, which I want to use those are my source images, my backgrounds, which I called backgrounds. And then I'm going to put them into this project that we are working on getting a better model from. How many images do I want? I don't know, 50? I only want 1 mug per image. How big? Gosh, I don't know. This might be trial and error. Let's go 30% bigger and 30% smaller, and we'll see how that works. And then this is going to isolate those, so cut those polygons of cups out. It's going to process the backgrounds. Then it's going to download them into an image generation process and then generate a synthetic data set. So this might take a few minutes here. I'm going to check out the chat and see if there's other questions. Gene, yeah, we will put this on the channel after it's done, for sure. Can you explain Magic Scissors? So Magic Scissors is an open source project that we just released. So if you go to github.com/roboflow/magic scissors, I think with a dash, you can read all about how it works. But it's basically an example of using our API to create an app on top of it. So this is an open source app that uses the Roboflow API to create synthetic data. And so if you want to add other features to this, you're more than welcome to. It's an open source app, and we're hoping that other people start contributing. We actually just released it this morning, so this could go horribly, horribly wrong because I've only done this once before, but I guess we will see. Let's double check on what's going on in here. So this should be, it's created a version, so it isolated the objects here, or did it? Not really sure. And I should have created a version of the backgrounds also. You know what? I'm going to create my own version because I don't like the way that it resized these. So I actually want to turn off resize. generate that guy. And then let's go make sure that isolate objects is on that other one. Magic Scissors is supposed to do this for me, but... Oh, it did. Why didn't it? I'm going to add OGs to these also, actually. So that way my coffee mugs will be pasted on there in a bunch of different ways. They're not going to do that much, though, because my coffee mug is white. But hopefully it'll give it just a little bit more variation on top of that background. Isolate objects. Okay, so that's what this was supposed to do. This cut them out of the background and crop down to them. Okay, and then let's go back and check out... Whoa, what happened here? There. Let's see what's happening with our training run. Okay, so it finished 74% map. That's pretty good. That's the one that we saw. We'll try that in our webcam here in a minute. Kate's got 23 of the 59 images annotated. So let's go check on this model. So okay, so this is actually predicting mugs in the test set. Okay. Doesn't like this orange one. Oh, when you turn the confidence down enough, it gets it. Not perfect. Okay. Let's see how we did. This was the model that we trained just with remapping the classes and turning down the augmentations. So now you can notice everything that it's predicting is a mug. That's a good start. Ooh. Oh, you know what? Kate's exiting me out of that, I think. I should have tested this in multiplayer mode. Let's see. Okay, so... Nope. Not sure what's going on here. I might need Kate to stop editing the dataset because I think it's exiting me out. But it's getting my mug okay. Maybe. I don't know. We'll wait for Kate to stop on that. Because I think it's canceling my my inference as images get annotated. Okay, so let's go back over here and finish generating our dataset. It looks like we're running up on time too, so I've got 5 minutes to bring this thing home. I think we can do it. Source images, backgrounds, coffee cup live stream. We're gonna do 51, 30, and 30. This is always the fun part about doing a live demo of something that you've never tested before, but getting a preview of real life. Oop! Also, my video didn't like that at all, did it? I don't know why OBS keeps changing the size of my webcam. That could be part of the problem too. Maybe I should just exit out and go to stream only. I don't think Magic Scissors is going to play nice with this. Oh, of course. As soon as I As soon as I open my dev tools, then it wants to work. But this 500 did. What did that 500? I might have to dive into later why that crashed. Hey, hey. That's the way to fix all computer science problems. You just gotta try it until it works. Nope, failed again. So I suspect that's crashing on something. I'll have to debug that. I'm gonna file an issue actually on that repo after this. But looks like Kate is almost done with these. Let's help her out. Okay, so Kate's done. Looks like there's one more mug left on here. Oh, maybe not. She's still working on it. We can watch her as she goes. Five to go. Four to go. Three to go. Two. One. And she's done. Okay, cool. So I'm going to add those to my data set and make sure I put them all in my validation set. And so now I've got my data set of 203 images. And now that Kate's out of there and we're not making changes anymore, let's double check this webcam again and see if that was the issue or if that model was just being weird. Nope, this model just doesn't really. Let's go just screen here. There we go. Ooh. Okay, not bad. It's getting that. Mug. So recall, this was trained with no people in it, just mugs. Actually, if I put it close to the thing, it's getting the mug. Okay. So I'm going to follow up after this. And when I slice this together into an actual video, we'll get some movie magic, and I'll pick back up here with the synthetic data, train another model, and demo how the synthetic data made it do better on ones with people. But hopefully you learned at least a little bit about what we can do to improve our data sets. Some of the things we did, we checked out the health check and learned about the problem with the classes. We adjusted the augmentation so that the model was seeing actual images that weren't junk. We re-annotated some of the images. We changed our validation set so that we are testing on images like we're training on or like we're going to be predicting on. We relabeled some of the images to be better, and we're going to, but haven't yet, remove some of the junk images that were already like turned upside down or were of clip art or things that are very dissimilar to what we're going to be inferring on, like this dirty mug labeled with things that aren't what we want to predict. So I think probably with another half hour and one magic scissors bug fix, we should be able to get a pretty good model here. So thanks a lot, everybody. Thanks, Kate, for helping me annotate. Hope you all enjoyed the stream. Let us know if we should do more of these in the future. I don't know. This is kind of a look into what a real computer vision process is like. It's not always A to B. It's kind of choose your own adventure and wander around the wilderness for a little bit. So thanks a lot, everybody. Have a good one.